Let's look at the next question. The next question that we do is question number 15. So the ratio between the altitudes is given as 3:5. We need to find the ratio between their median, perimeter and area. So let's try and prove these two triangles similar and see if this will help us in getting anything. So in triangle ABX and triangle DEY, what do we have equal? Number 3, angle ABX is equal to angle DEY. Basically this angle and this angle I'm saying are equal, because since the bigger triangles are similar, this means this is the corresponding angles of similar triangles are equal. Next I have angle AXB is equal to angle DYE is equal to 90 degree. This is given. Let's just mark this angle and this angle are 90 degree. So what do we get from here? We get number 5, which is therefore triangle ABX is similar to triangle DEY. This is by AA test. Let's see what will we get from here, which means AB upon DE is equal to AX upon DY is equal to BX upon EY, and since the ratio of the altitude is given as 3/5, this is equal to 3/5. This is corresponding sides of similar triangles are in proportion. Good, so that finishes this part for us. We still need to find median, nothing done, perimeter not done, area not done. So let's look at what we have. Since triangle ABC is similar to triangle DEF, what we have is AB upon DE is equal to AC upon DF is equal to BC upon EF, and since AB upon DE is common between 6 and 8, this is equal to 3/5. Now if I can add the numerator, what I get is AB plus AC plus BC upon DE plus DF plus EF. This is nothing but AB upon DE, which is 3/5. So this is my perimeter. This part of the question done, where we've calculated the ratio of their perimeter. Let's look at the area. Now since triangles are similar, therefore area of triangle ABC upon area of triangle DEF would be in the ratio of the square of their respective sides, which means AB upon DE whole square, which is 9:25. 3/5 square, that's 9:25. So area is well done. Let's look at the third part. The third part is the corresponding median. So we basically need to prove that the some relation between the sides so that we can prove them similar. So let's look at this. In triangle ABL and triangle DEM, what we have is angle ABL is equal to angle DEM. This is from 3. We have the same angle. ABX and ABL are the same angles. Now what we also have is from 8, what we have is AB upon DE is equal to BC upon EF. This is from 8. Let me just change the order. Let me take this here and the BC down, which means I have AB upon BC is equal to DE upon EF. Let's divide the denominator by 2, which means AB upon half of BC should be equal to DE upon half of EF. I have divided both denominators by 2, and half of BC is nothing but BL, right? So AB upon BL is equal to DE upon half of EF is nothing but EM. Since BL is equal to half of BC and EM is equal to half of EF, since these are medians, which means from 12 and 16, what I get is AB upon BL is equal to DE upon EM, and the included angle is equal. Since two sides are in same ratio and included angle is equal, what we get is triangle ABL is similar to triangle DEM by SAS test. What this means is AB upon DE is equal to BL upon EM is equal to AL upon DM, and I already know AB upon DE is equal to 3 upon 5. So what they want is the ratio of the corresponding medians, which is nothing but BL upon EM, the answer for which is 3:5. Good, interesting question. Let's look at the next one. The next one that we do is question number 20. So let's look at question number 20. It says in triangle PQR, L and M are 2 points where on the base QR such that angle LPQ is equal to angle QRP, and so two sets of triangles angles are equal. We need to prove that these two triangles are similar. Let me just draw these two triangles separately so that's easier for us to understand. In fact, not required really. This is PQL, this is PMR, this is single line, this is single line, angle Q and angle P here are equal. So by AA test, these are already similar. So in triangle PQL and triangle PMR, what do we get? Number one, angle PQL is equal to angle RPM. This is given. Next. Number two would be angle QPL is equal to angle PRM. This is also given, which means what I get is therefore triangle PQL is similar to triangle RPM. That's what they wanted us to prove. It's similar to RPM. This is by AA test. So first part of the question done. Next part. The next part is we need to prove that QL into RM is equal to PL into PM. So let's do a CSST for this. Let's do the side which will be in proportion. So PQ upon RP would be equal to PL upon RM will be equal to QL upon PM. Let's see if this helps us in any way. This is corresponding sides of similar triangles are in same proportion. So QL into RM. So they want QL into RM. So this is what they're basically looking at. What means this is QL into RM. So I just cross multiply here. Should be equal to PL into PM. So this is done. This was simple. This is the second part of the question. Hence proved. Let's look at the last part of the question and see what do we have to do to get there. Part 3 says we need to get PQ square is equal to QR into QL. Let's see, I hope you remember if we can how to figure out which two triangles to prove similar. In this case, let me to put PQ here and let's take QL down. Let's see if this helps me. So if I take QL down, this becomes QR upon PQ. PQR, that's the big triangle, PQR, and PLQ, which is this small triangle. So let's try and prove these two triangles similar in triangle PQR and triangle PQL. Let's see what we get. So I will draw these two triangles separately so that it's easier for us to look at this. So this Q is double line, R is single line, and PQL. This P This is Q and this is L. This is double line and this is single line. I think I've already visually got my answer, so shouldn't be a problem at all. So angle PQR is equal to angle LQP. This is given. And number 8 would be angle PRQ is equal to angle LPQ. This is also given, which means therefore triangle PQR is similar to triangle LQP. AA test. Let's figure out the CSST for this, which means PQ upon LQ would be equal to PR upon LP, which would be equal to QR upon QP. So they want PQ square, which means I am looking at these two. So if I cross multiply, what I get is PQ into PQ. That's PQ square is equal to QR multiplied with QL. Done. That's what they wanted me to prove. Done. So hence proved. Good. Let's look at the next question. The next question that we do is question number 23. So question number 23 says, in triangle ABC, AP is to PB is 2:3. So if this is 2x, this is 3x. Next, PO is parallel to BC and is extended to Q such that CQ is parallel to BA. So this side now is parallel to AB. Perfect. Find the area of ratio of area of triangle APO is to triangle ABC and then the second one. So let's see if we can prove any two triangles similar. First one, we are looking at APO versus ABC. So APO versus ABC. That shouldn't be too difficult. This looks fairly simple. So in triangle APO and triangle ABC, what we have is angle PAO is equal to angle BAC. This is common angle. The next one will be angle APO is equal to angle ABC. These are corresponding angles. Done. So by AA test, these two triangles are similar, which means I should be able to figure out my answer. Therefore, triangle APO is similar to triangle ABC by AA test, which means area of AP upon AB should be equal to AO upon AC should be equal to PO upon BC, which means AP is given as 2x and AB is given as 2x plus 3x, that's 5. This is CSST. And now we need to find the area, ratio of the areas, which means area of triangle APO upon area of triangle ABC would be equal to AP upon AB whole square. In this case, 2 square, which is 4, and 5 square, that's 25. So the first part of the question done. The answer is 4:25. Good. Let's look at the next part of the question. The next part of the question is APO, which is this triangle here, and COQ. Again, I should be able to prove them similar because this angle here and this angle will be equal. These are alternate vertically opposite angles, and since AB is parallel to CQ, which means angle A here and angle C here will be equal. These are alternate angles. So I should be able to prove them similar. So if I have the dimensions of AO and CO or PO, I should be able to figure out. Let's see if I can use something to get dimensions of AO and CO yet. So since PO is parallel to BC in triangle ABC using basic proportionality theorem, what I get is AP upon BP is equal to AO upon CO is equal to 2 upon 3. So I've got some relationship between AO and CO. Now I should be able to get the second part easily. So in triangle APO and triangle CQO. What I get is angle AOP is equal to angle COQ. This is vertically opposite angles. And then the next one would be angle OAP is equal to angle OCQ. These are alternate angles, which means triangle APO is similar to triangle CQO by AA test, which means I will have AP upon CQ is equal to AO upon CO is equal to PO upon QO, which is equal to 2 upon 3. This is from 7 and this is CSST. Done. Which means area of triangle APO, I didn't write it properly, triangle APO upon area of triangle CQO would be equal to AO upon CO whole square. In this case 4:9. Good, interesting question. Let's look at the next question. The next question that we do is question number 24. Question number 24 says, in triangle ABC, AD is perpendicular to BC, okay, and BE is perpendicular to AC. Okay, fair enough. We need to prove triangle ADC and triangle BEC are similar. So let's look at triangle ADC. This is my triangle ADC. This is D. This is C. This is A. And triangle BEC. Okay, so this is BEC. This is E. This is C. This is P. So I have an angle equal, which is 90 degree, and angle C, which is common. So I've got my answer. In triangle ACD and triangle BEC, what I have is angle ADC is equal to angle BEC is equal to 90 degree. This is given. Next, angle ACD is equal to angle DCE. This is common angle, which means therefore triangle ADC is similar to triangle BEC by AA test. So my first part of the question done. Absolutely no problem. Very simple one. Let's look at the second part of the question. It says CA, CE, CB, CD. Let's see CA, CB, CE, CD. I think we should get this from the CSST of this one itself. Let's try. So since these two triangles are similar, what I have is AD upon BE is equal to AC upon BC, which is equal to DC upon EC. They want CA into CE, which means these two. So I will take this, and this is CSST. Let me just cross multiply. What I get is CA into CE is equal to CB here multiplied with CD there. Perfect. So that's this second part of the question, hence proved. Let's look at the next part. The next part says prove triangle ABC is similar to triangle DEC. ABC, so that's the big triangle. Let's just draw the big triangle here once again. This is CAB, and then the next one is DEC. Okay, so this is the small upper triangle here, CED. Do we get anything here? I have angle C common, so that is simple, but I need one more thing. Any other angle common? I can't see any other angle which is given equal. Yes, no other angle is given equal. Can I try some ratio of sides? Is there any ratio given? So is there a ratio of AC upon BC? Yes, I have a ratio of AC upon BC. Is there a ratio of CE and CD? Yes, I have a ratio of CE and CD. So AC is DC. Perfect. So let's just write that down. In triangle ACB and triangle DCE. Yes, ACB and DCE. What we have is AC upon BC is equal to AC upon BC is equal to DC upon EC. This is from 4. And number 8 would be angle ACB is equal to angle DCE. This is common angle. Since two sides are in the same ratio and included angle is equal, therefore triangle ABC is similar to triangle DEC. By ABC is similar to DEC by SAS test. Done. So this part of the question done. Last part, let's do the CSST for this and see if we get something, which means AB upon DE is equal to BC upon EC is equal to AC upon DC. So CD into AB, which means this one and this one. Let's cross multiply. What we get is CD into AB is equal to CA here multiplied with DE. Hence proved. That this was CSST. Good, that finishes this video for me. Before I leave, let me give you some homework questions. Homework question for you from this exercise would be 16 and 22. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.